thank you all for joining us. Today's webinar, Boost Your PCB Module Reliability with DOWSIL Gels, Encapsulants, and Conformal Coatings, is presented by Dow. The presenters today are Christian Zitzman and Thierry Corman. My name is Trey McDonald, wish you well, and I'll be moderating today's event. You can send us questions by typing them in the question box located on your screen, and our panelists will answer them at the end of the presentation. We're recording today's event and we'll send you a link via email when the slides and video have been posted to the UL Prospector Knowledge Center. With that, I'll turn the presentation over to Christian. Christian?
Yeah, thank you, Trey. Hello, everyone on the phone, and thanks for joining our webinar today. Within the scope of this webinar, we would like to answer the questions, why does a PCB and its components need protection? We also would like to explain what kind of properties a material needs in order to work as a protection material, and why especially silicones are suitable for protection applications. Furthermore, we will see how to select your protection solutions, and we'll have a closer look into the range of DOWSIL protection materials like coatings, gels, encapsulants, and some more specialized materials. After finishing the presentation, we will open up for Q&A. So, why does a PCB and its components need protection? Indeed, there are three main reasons it comes down to. First one is electrical failure, which can have different causes like corrosion, thermal stresses due to the CTE mismatch of the material at different substrates used, vibration, mechanical shock or impact, and the exposure to harsh environments. Another reason is overheating. Due to the fact that parts today are getting smaller and smaller and have more functionality, the temperature increases at the same time to a high extent. And maybe a third not so obvious reason is the protection from competition. You may not want to see others to look at the design of the components used on your board. So what kind of properties do materials need in order to work as protection material? First, they need to be good electrical insulators. They also need to be able to completely cover and seal all of the components used on your board. Therefore, they require good wet-out capability, and depending on the level of protection you require, they also need to provide a certain level of adhesion. And of course, all this needs to be durable to resist against heat, cold, water, or also chemical exposure. In addition, those materials need to work as stress reducers in terms of mechanical stresses like vibration and shock, or thermal stresses like the CTE mismatch or overheating. Just for those of you who are not aware of the term CTE, it stands for coefficient of thermal expansion and indicates the dimensional change of a material when temperature changes. So why silicones for protection applications? Silicones are indeed hybrid molecules, so they're made up of organic and inorganic chemistry. While organic polymers are easier to process and provide a wide range of properties, but are less thermally stable, inorganic chemistry or inorganic materials like glass, for example, are more thermally stable and provide an optical clearness, but they are more complex to process. So in a way, silicones combine the benefits of both chemistries while somehow compensating the limitations. As a class of materials, silicones generally offer demonstrable benefits over organic solutions like acrylics, urethanes, or epoxies. Indeed, they are able to provide a maximum protection against mechanical stresses that can be caused by thermal cycling or CTE mismatch by the use of a silicone gel, for example. Due to their low modulus and high elasticity, they also provide extraordinary protection against shock and vibration. And What is well known for silicones is their thermal stability. So indeed they are able to provide a reliable performance at sustained temperatures between a generalized temperature range of -45 to 200 degrees with the potential to extend in both directions. They also do have a great hydrostability and a strong resistance to a wide range of chemicals and especially to UV radiation. Overall, they do not have the toxicity issues of organics, which helps to reduce or even eliminate the special handling precautions. And in case you would like to heat cure material or a silicone, it does not impose it imposes a significantly lower impact on M properties compared to organics. They are also simpler to process without the need for oven drying or concerns about exotherms. And if you would like to rework your module, you can do this with a silicone, as it is quite easy to repair. Overall, silicones provide a wide range of special features which are targeting multiple functions like thermal management, improved processing efficiency and others, which you will learn more about in the following slides. So this graph in a nutshell shows you which material to choose for your application. So in case you have a very flat board design which requires only a very thin layer, a protecting layer, you may go for or choose a conformal coating. In case you have some taller components on your board, this may require a so-called spot protection coating. These materials have an increased viscosity compared to conformal coatings and can simply build up higher to be more able to protect these taller components. And if you have a very complex landscape of components on your board with different sizes, you may want to choose a gel or an encapsulant in order to pot the whole module. So in the following slides, we would like to have a closer look into the range of DOWSIL protection solutions, starting with coatings, which will be presented by Thierry.
Thank you, Christian, for all those explanations. So as you mentioned, we will now start with the coatings material with our lot of properties, especially a greater thermal stability regarding a range from -45 degrees C up to 150 degrees C. We also have improved stress relief with the range of elastomeric coatings. On the other side, the elastoplastic coatings offers an improved mechanical resistance. For both of those coatings, we can have a fast heat or room temperature curing process. And depending on your process, you can choose a low viscosity for high-speed production or go to a higher viscosity coating for a better thickness control. All of our coatings meet certified agency rating like UI 94 or 746 and some other specified rating. Now regarding the limitations of the coatings, we recommend to use them for thin layers, like less than 1 millimeter, and for simple or flat designs. Regarding our portfolio for the elastomeric coatings, we can offer a broad range of products with different stress relief levels, with a low hardness, with a very high stress relief, and high hardness, where we can have a lower stress relief but still suitable for some application. All those coatings are available with different viscosities or also with different cure speeds depending on your final process application.
Okay, so now we will have a closer look into the gels. Indeed, those materials are the softest we offer in the protection materials range, so they are quite highly stress relieving. as they can, and thus they can provide a maximum protection against mechanical stresses. They're also, to a certain extent, self-healing when you torn or cut them. They're quite easily repairable. Due to the very low viscosities those materials offer, overall they have a very good surface wetting, which is important just when you think about all the different substrates and surfaces used on your board. And in addition, also challenging is the adhesion buildup on those boards. So these materials, due to their tackiness, can provide reliable physical adhesion to common surfaces without the need for primers. What can be seen as a limitation is the protection against mechanical impact, simply due to the softness of those materials. And what also needs to be mentioned, they have a quite high CTE. So in case you fill up your module to the top and put a lid on and screw it down, at temperature exposure, those materials will put a lot of pressure in your module. So it can lead to the damage of certain components up to the breakage of the whole module. So this definitely needs to be considered when using this kind of material to pot your module. This table shows a number of our what we call standard gels. As you can see, most of them provide quite low viscosity, and we ordered them in terms of hardness or translated to stress relief in the end. You can also see there are different cure temperatures, so depending on your need in your process, you might choose one for the other. And don't worry, you will get the slides later on, so we will not talk about each of these products, but you can have a closer look when you get the presentation. One gel we would like to highlight here is the DOWSIL EG3810, which has some key features. One to highlight definitely is the thermal stability from -60 to 200, which is above the standard gels, which are usually at -40 to 150. It also provides a reliable protection against damaging environmental conditions. Here we talk about chemical exposures, or especially temperature exposures. It also offers a superior buffer against mechanical stresses. And as you can see on the right-hand side in the table, on the bottom, dielectric strength is quite high. So really, this material offers first a good dielectric strength, but in addition, this is also reliable over the lifetime of the module. And finally, it cures quite quickly, as you can see when you look at the heat and the cure schedules. So the benefits of this material are really providing a long-lasting, reliable device performance in extreme conditions, as you can see by the temperature range. It also protects very delicate leads against thermal cycling, impact, and vibration. So on the right-hand side, you can see a module that is protected or encapsulated with this gel, and it offers improved productivity, especially due to the very fast cure of this material. Typical applications are power conversion modules like IGBT modules, automotive under the hood PCB assemblies, or industrial sensors and actuators. So we have put a graph here that improves the thermal stability at 200 degrees. So you can see the penetration level, or you may say the hardness of the gel over 1,000 hours remains absolutely stable. But you can also see the limitation. So when you expose this material to 220 degree, penetration goes down. So really here's a limit at 200 for the lifetime of the module. Another group of gels we want to highlight as well are the tough gels. As you can see as well, very low viscosity again. A quite unique property of most of these materials is the ability to build chemical bonding to substrates at room temperature. You can also see there are different cure schedules possible, so cure temperatures at which these materials cure.
Okay, so as we saw, the gels have some limitations regarding the big CTE or the low mechanical resistance, and one of the alternatives of those products are the encapsulants. The encapsulants are, as they are higher hardness, they have a greater resistance to abrasion and damage. They have the same property as the gels. They are easy repairable, and they are also available in a wide range of viscosity. The primerless option is also available for the encapsulants, as well as the thermal conductivity. And most of the encapsulants also meet the requirements of the UL 94 certification. Now, on the limitation standpoint, because of the higher hardness, we have, of course, a lower stress relief into the module. DOWSIL material standard encapsulation offer a really broad range of materials with a very low viscosity to higher viscosity, very low hardness to higher hardness. The selection of those encapsulants would only depend on the final application requirements. If you have no very typical application that needs some thermal conductivity, then we can go for a thermal conductive encapsulant, where the thermal conductivity can start from 0.5 watt per meter Kelvin up to almost 3 watt per meter Kelvin, with also different viscosities. In this case, if you want to learn more about the thermal management, we invite you to go to the recorded webinar of the hot topic about thermal management. Primerless encapsulants are also a solution available to have a really weatherproof module with different viscosity and hardnesses as well. So this is really an optional feature of the encapsulant, where the strong adhesion against the substrate is needed for very harsh environment conditions. Now, with all those ranges, we covered with a kind of standard protection solutions. We are also able to provide some of specialized solutions for very typical application. Like, for example, space grade application with our DOWSIL 93500, a material with a very low level of volatile, and make some, it's very proven for space grade application following a determined ASTM norm. The DOWSIL Q36679 gel is a fluoro-based material which has an enhanced resistance against solvents and fuels. There is also UV curable portfolio, which allows you to have a long working time and cure the material by UV exposition to protect your module with low temperature applications. Optical applications need also to be protected, and the DOWSIL EI 1184 is one of the solutions that we can offer for such application, with a very high transparency and a good reliability for optical application in some harsh environments. So high heat, 150 degrees, high humidity, UV irradiation. So this material can as well be used for indoor or outdoor application. And finally, transportation. DOWSIL EE 3000 and SILGAS 170 meet the requirements for fire protection standards for public transportation applications. So those materials really meet all the standards to be used in common application for the public transportation. So with this webinar, we covered more or less the standard solutions, and we will be more than happy to answer your questions from now.
And as you can imagine, we will probably not be able to answer all questions in the remaining time. But be assured that your question will be answered after the webinar. So you will get contacted by email and get answers to your questions. So we will now have a look at the questions that we have received so far. Maybe starting with this one. Here's a question about if we can apply silicone over conformal coating on IC lids to augment resistance to shorts. So actually, yes, you can do it in principle. The question is always if you get a certain adhesion on the conformal coating. But the question is as well, why you would choose first to use a conformal coating and later on encapsulate it or cover it somehow with another material. So in this case, this needs more explanation why this should be needed, because in my opinion, you would maybe just go for one material to provide both the protection of the lids and the insulation strength.
Okay, let's pick up another question. How to protect LED PCB where you are unable to use a VOC product around the phosphor of the LED or around the secondary optics used on the LED. So for these questions, some of our products we're testing according a chemical compatibility test that is mentioned on the CRE website. You can find there, depending of your LED type, which material is the best one for your application.
So the next question. The question here is if a fully waterproof durable coating exists. Well, let's say it in this way. Silicone conformal coatings are waterproof in a way. So if you talk about water, they are waterproof. So you can put water on them. There's not an issue. It will not go through. In terms of water vapors, of course, they can permeate through the silicone matrix because silicones in general are permeable. So in this case, you will need to have a good coverage on your board, and then there should be no issue there. But of course, it needs to be assured that the surface is fully cleaned in order to have perfect protection. But I think what this question is going for, if you can immerse the PCB in water, and oftentimes the greater issue is the insulation strength, because conformal coatings are quite thin, so you may not have the right insulation strength provided by this thin layer in order to avoid short circuits, for example.
Okay, next question. Other than OEM requirements, why should we apply conformal coating to PCB? Just to have a better reliability of your PCB, to to reduce the short circuits issues, to improve about any mechanical or also chemical ingress if your application is in that case. Whatever, yeah, and environmental aggression that could be possible for your PCB, putting a coating or whatever other solution to protect your PCB is always a good point to have a higher quality of electrical or PCB module at the end for your final customer.
So here comes the next question. In which cases we should better use tough gel, not just the gel or encapsulant? I think one of the main reasons that I just indicated during the presentation is that these materials can provide chemical bonding to substrates and can do that at room temperature, which is not possible with the primerless encapsulants. Yeah, so primerless encapsulants you need to heat cure in order to achieve a level of adhesion. So this is definitely one reason. Of course, there could be other reasons like the hardness those materials provide, which are in between standard encapsulants and gels. So they touch like an encapsulant, so have flat surface. They are like more like an elastomer, so they are not tacky. So in case you do not know tacky materials allowed, but you don't want to have material as hard as an encapsulant, it could be another reason to go for a tough gel.
So do you have information on outgassing volatiles from materials post-curing? So depending on the grade of the material, we have certain material with what we call CV or controlled volatile material, where we have a limited amount of outgassing of volatiles. This is always depending on the technology behind. This is always something we can solve more or less with post-curing solution or with a longer room temperature curing. But yeah, we can have some information about the outgassing of those materials. This is something we can get more or less easily depending on the technology of the silicone materials.
And just to add here, there's a big topic around silicone volatile, silicone contamination, and so on. We can share information about that. It's important always to discuss your application in more detail in order to understand the issues you may see or already have, to somehow answer your issue or give you information why you have this issue. So it may not be obviously what you think. So if you would like to discuss more, please feel free to contact us or your contact at your supplier to discuss more about this topic. So let's have a further look. Here's a question about page 28. Let's have a look again.
When you mentioned the application in transportation, is it the same as automotive application? Yes and no. The problem with this question or norm depends on the OEM behind the application. Typically, each OEM have their own standards with their own requirements. So it is possible that some OEMs use some existing norms that they just kind of copy paste or use for their qualification. No, this transportation norm is not necessarily for automotive industry.
So I can take this one. Here's a question: how does the resistivity of a silicone behave after prolonged exposure to humidity? This depends a little bit on the type of material. So if it's a gel or an encapsulant, so gels can take some more water vapors. This is what you are referring to in the end. So it will somehow limit the resistivity, but usually to a level that is fully acceptable for the application. In terms of drop, we will need to. It depends on the exposure, the material used, as I said. So you just give you a very rough idea. We are usually at volume resistivities of 15 to the 10th or 12 to the 10th, 13 to the 10th. Maybe for a gel that can take a bit more vapors, it may go down to 10 to the 10th. Something like that, and there might be some applications where this is where you need to have a closer look if it's an issue or not. Usually for electronics applications, it's not really overall.
Okay, so let's pick up the last question. Are there other important variables other than hardness for conformal coating? This question can start, I would say, a big debate depending on the requirements needed for the application. All the variables are important, and depending on what you already have in place as well in the production line. For example, viscosity is the viscosity. Can the spray head be handled by your current spray head? Do you need, for example, stress relief properties? Also, what can I find other for the coatings? Also, yeah. What's the VOC level you are accepting with your application, or you prefer to go for a low VOC version of the coating? Do you need some UV dye for quality inspection, or you prefer to go without UV dye? Do you need some improved mechanical ingress, or with I would say a softer material? So there are a lot of parameters that will influence the choice of coating, and not only the hardness. So this is, I would say, difficult to answer it in a general way. As for really select the right coating, we need the final application that is targeted with the limitations of the production line or for the requirements.
Okay, just really a last question here, what I want to tackle, which will be, I think, interesting for all of you. What about contamination of silicon vapors near mechanical parts? To answer that easily, and we can share that with all of you, we have some publications about that topic that gives you, I think, a very good understanding where risks are and where you don't need to expect some risk. So it's not easy to answer that in one sentence or two. So I rather prefer to give you some good information on hand, that you have a better understanding overall about silicon contamination and the different mechanisms behind. Because this is a topic oftentimes at customers, so we will share that with you, so you have really a better basic information. Yeah, but thanks for the question.
All right, guys, that does look like all the time we have for questions today. A big thank you to our audience for attending. We also do encourage you to check out, we mentioned earlier in the presentation, the hot topics webinar earlier. We do encourage you to check that out. It was really a great one. Again, a big thank you to our audience for attending, and have a great rest of the day, everyone.